Okay, so good morning, everybody. Today I'll talk about sex and caste effects on the sensitivity of the sense of vibration in honeybees. So in a honeybee colony, we can find the worker bees, which are non-reproductive females, and they constitute the majority of the individuals within a colony. Then we have drones, which are reproductive males, and they are usually present in the colony in the period that goes between spring and midsummer, and they are very important for spreading the genome of their family line. And then we have the queen, which is the only reproductive female, and she passes through two different stages, from being a virgin queen to becoming a laying queen. And this is important to stress out because the behavior of the queen changes consistently between these two different phases. When she's a virgin queen, she's very active and competitive because she needs to fight for the supremacy in the colony against the other sister queens, which also wants to become the queen of the colony. So when there is a winner, she will fly out and mate and become soon a laying queen. And from that day on, her job is just to be cuddled by workers and laying eggs every day in order to provide a new generation for the colony. So vibrational signals are widespread in honeybee communication. We already know some signals which are used in worker bees and by virgin queens. Here I have some examples for you. So starting, for example, from the top left, we can see a worker bee which is performing a stop signal. So she is communicating to the dancer that she has to stop recruiting other bees. Then in the middle picture, we have a worker bee performing a DVAV, so a dorsoventral abdomen vibration. That means that the bee starts drumming her abdomen onto a substrate, which could be another bee or a comb, for example, queen cell. And this signal is used to modulate other signals or other behaviors. Instead, in the picture on the right, we have represented two queens, one which is still enclosed in the cell, and she's generating a quacking, and one queen which is outside and generating a tooting. And here I can make you listen a tooting. So the signals may be low-pitched or high-pitched, but let's say that the main frequency range is between 250 and 500 hertz. The vibrational sensitivity has been consistently studied in worker bees, so we know already that they are able to sense vibration through the subgenual organ, which is located in the tibia of their legs and is particularly sensitive to the vertical component of the vibrations. So the aim of my study was to explore the sense of vibration comparatively in workers, virgin queens, laying queens, and drones. But in particular, I was very interested to see if there was any difference between virgin queens and laying queens, because, as I said, their behavior changes during the two phases, and also because the object of my PhD is to study queen communication. So I ran a behavioral experiment, and I took into consideration the frequency that goes between 350 to 500 hertz. I placed the bee in a petri dish and the petri dish onto a combination of vibrational exciter and an accelerometer so that I could control the amplitude of the vibration I was giving and figure out the threshold, which was the lowest amplitude for which I found more reaction for the stimuli than the sham-stimuli. So what comes out from my result was that for worker bees, at least when they are enclosed in an isolated arena, they have a high sensitivity. So here we are around 300 millimeter per square second. And if I compare my result to previous result, that, for example, as you can see in the right graph, there is a resume of previous studies. And it is shown from the black line with black squares. A study that was performed in the hive. So my results are like 1 order of magnitude below, so we would be like here, yes. And this difference is probably due to the fact that the other experiment was run within the hive, so there were probably the disturbances of the hive influencing the sensitivity. My hypothesis regarding the queens was confirmed, so there is a difference between virgin queen and laying queens. Virgin queens are definitely more sensitive. Here we are also around 300 to 200 millimeter per square second, so they have a sensitivity similar to the one of the workers, while laying queens have a lower sensitivity, and that's quite clear. But also, I found more variability within the subject that I tested for laying queens that in turn made me hypothesize that the older the queens become, the less sensitive they are. And regarding drones, they also showed a very low sensitivity. But that's something I could expect because drones are more important outside the hive than inside the hive. Yeah, this is a sum up of the means of vibrational sensitivity for groups. So it's quite clear that virgin queens and workers are more sensitive. So to conclude, I can say that yes, sex and caste have effects on vibrational sensitivity in honeybees. And a high sensitivity is required by virgin queens and is crucial if they want to survive. So that's probably the explanation why because they need to have it if they want to detect signals of the other competitors and survive. Otherwise, they are killed. And instead, a high sensitivity for worker bees means just efficient everyday work, because worker bees are involved in several activities and they are the ones who lead the hive, so obviously they must need an efficient communication as well. And thank you for your attention.